Only one person is here. Please, let me tell your colleagues to join. I'm going to start immediately. I want us to go to a reasonable extent, please. There's no there's no time to waste. In fact, the three of you that are here, I'm going to start. So please just ask them that they should join, or if they don't join, I will start the class immediately, and they will just have to fall back to watching the video. So yesterday we stopped at question number 30. I'm going to move on to question 31 now. So question 31. So now straight up to question 31. Straight up to question 31. Now in question 31, it says that we have a 10 kilogram mass which is dragged along a horizontal table by a force of 60 newtons. If the force is inclined at angle of 30 degrees to the horizontal and the coefficient of dynamic friction between the mass and the table is 0.15, calculate the acceleration of the mass. So what you would do is that you would first of all draw the mass that want to be pulled. So that is so we have the mass. So this mass is 10 kilogram and is to be dragged on this floor. Then the question says that the 10 kg mass is on horizontal table, is to be pulled by a force. So the force is 60 newton and it is inclined at an angle of 30 degrees to the horizontal. So let us draw the force. This is the force, which is 60 newtons, and the angle of inclination is 30 degrees. So you have to learn how to sketch things as well. So, and we're given the coefficient of dynamic friction. The coefficient of dynamic friction is 0.15. Now the difference between dynamic and static friction is that dynamic, you use it when the body is moving. Static, you use it when the body is not moving. Okay, so quickly, now what are the things that we need to consider in this place? Since this surface is not a smooth surface, it means the surface is a rough surface. Hence, there is presence of friction in this surface. There is presence of friction in this surface, and that implies that we have frictional force moving in this direction. Now, one thing you must know about frictional force is that frictional force always acts in a direction that will oppose the motion, not necessarily the direction of the applied force, but most times it's always opposite the direction of the applied force. But most of every single time, it is the direction that opposes the actual direction of movement. That is what this thing is going to move towards. So that I've been able to do the proper sketching now. So what you need to do is that you need to find your frictional force. You need to find the net force in this place and equate it to MA. So yesterday I taught you that the equation we always use is that resultant force equals MA. So let's find our resultant force in this place. So to find my frictional force, we know that the weight of this object is acting downward, and that will be 100 newtons. And here we have normal reaction N. So that is how you analyze questions like this. You have the normal reaction. So in the vertical region, what we have is that N is acting upward, so that's positive N. 100 is acting downward, so that's minus 100. And from what we know, this resultant force is always equal to MA. But in the vertical plane, this box is not being lifted up, neither is it being pressed down. So that means that as far as the vertical movement is concerned, no movement. Hence, acceleration is 0. Therefore, this will be equals to 0, which means that our normal reaction is 100 newtons. So don't forget, frictional force is mu times normal reaction. Frictional force is mu times normal reaction. So in that case now, our mu is 0.15 multiplied by our normal reaction as we have gotten it is 100 newtons. So automatically when you multiply this, you have 15 newtons. So from this place, our FR equals 15 newtons. And we need to resolve this thing to the horizontal. Since the angle is made with the horizontal, then when we resolve this guy to the horizontal, we'll have 60 cosine 30 degrees. Hence, for the horizontal now, the resultant force will be 60 cosine 30 degrees minus 15. That will be equal to MA, where M, what's our M? M is the mass of the object, which is 10 times acceleration. So 60 cos 30, if you press that on your calculator, that should give you 30 root 3. Yeah, cos 30 is root 3 over 2. I believe we all know that. So that will be 30 root 3 minus 15 equals 10A. So was the answer given as a decimal, or was it given as in standard form? Okay, as a decimal. So with that, let's do that. So we have 60 cos 30 minus 15. So that is 36.96 equals 10A. And that implies that A equals, so you divide both sides by 10, that will be approximately 3.7. So 3.7 meters per second squared. And that is how we solve question 31. So let me move to question 32 like that. For question 32, we have this plane. So let me quickly sketch that. So we have this. Please, guys, how we do it. So because of time, I will not be asking too much question. So if you don't get anything, you just have to indicate in the chat if you need me to re-explain anything because of our time. So this thing is suspended like this. This one is 5 kg and this one is 8 kg. Okay, so according to this question, it says that we have the 8 kg over a frictionless pulley, and there is a force of friction between the 5 kg mass, and table is accelerated at that. So basically, we need to analyze this guy. We analyze the one on the table, and we analyze the one in the that is hanging. So first of all, you need to know that weight of the body will be acting downward. So here, let's call this one M1 and let's call this one M2. So the weight of the body that is acting downward is M2G. Now, whenever you have a rope that is acting on something, a rope is attached to something, and then the force is acting in one direction, then the tension will always act in the rope in the opposite direction. And so if we are considering that this 8 kg is pulling downward, then the net force will be M2G minus tension, which will give us the resultant M2 times acceleration. You see, it's still working on the fact that resultant force equals MA. And how did I get my resultant force here? There are two forces acting in opposite direction, M2G and tension. And because we consider that the favorable side is the M2G side, which is the weight of this mass, hence we make it the positive one and we make T the negative one. If we are considering that this object is being pulled up, we would have said T minus M2G equals M2A. So anyways, resultant force is always equals to mass times acceleration, like I've taught you. So now in this place now we have M2 is 8 multiplied by 10 minus tension equals this is our M is 8 times A. I think we were given the acceleration in the question already. Yes, the acceleration of 8 kg downward is 4.5 meters per second squared. So I don't need to write A. 4.5. So that means that 80 minus T equals, so what is that? 8 times 4.5, that's 36. And if you do this very well, that means that T will be 80 minus 36, and that will be 44 newtons. I've gotten that. So let me go to the upper part here. Since this surface is not a smooth surface, there will be friction. So where will the friction act towards? Friction will act towards this place. Since the motion is being dragged like this, that means that the tension is now dragging this upper body like this in this manner. So if you analyze the motion in the upper body, you will have what? Since T is the, now if you look at it, 8 kg is pulling down. As it's pulling down over the pulley, these two will be rolling to the right as well. As 8 kg is pulling down, this will be rolling to the right. That means that this tension, the same tension is in a string because they are the same string. So this same tension will be doing the rightward pulling here. So you have T minus frictional force. At the same time, I told you that resultant force equals to MA. What M are they pushing here? That's our M1 times A. By the way, in this system, there will be the same acceleration and there will be the same tension. So we already have our T, which is 44 minus frictional force, which we are looking for. Then our M1 is 5 and our acceleration is 4.5. So if we do this very well, FR will be 4.44 minus, so 5 times 4.5, that's 22.5. So 44 minus this, so that's 21.25 newtons. So the correct answer is 21.25 newton. So let's take note of that. That's question 32. Question 32. So let's move on to the next question. Oh, sorry, 21.5. I got 21.5. 21.5 newton. Okay, so let's move to the next question. Question 33 now. Question 33 says that calculate the upthrust on an object of volume that, so we're given volume equals 500 cm cube. So it is always important that in this cm cube you convert it to meter cube. So this is 500. Now centimeter, I've used it severally in this class, is 10 raised to power minus 2. Since it is raised to power 3 in this case, you put 3 here, then you put your meter cube. So that means that we have 500 times 10 raised to power minus 6 meter cube, which is like 5 times 10 raised to power minus 4 meters cube. So that's our volume. Then what else do we have there? We have the density of that guy. The liquid of density 10 raised to power 3 kilogram per meter cube. So density is 10 raised to power 3 kilogram per meter cube. Now take note, upthrust is rho Vg. Upthrust is rho Vg. Rho is the density of the liquid. V is the volume of the substance that is being immersed, and G is acceleration due to gravity. Please take note of that. So in that case now they say calculate the upthrust on an object which is what? Partially immersed in a liquid of density 10 kilogram per meter cube. Now in this question they say that it was partially immersed. Now even though that question did not give us much information, because when you say partially immersed, it can be like 1/3 of it was immersed, 2/3 of it was immersed, 1/4 of it was immersed. But in this case, we weren't given any information, so we can assume that half of it was immersed. But before we even do that, let's find the normal upthrust if it was fully immersed, if it was fully submerged inside the whole thing. That would be rho Vg. So rho is 10 raised to power 3, V is 5 times 10 raised to power negative 4, and G is 10. So when you do this very well, everything here will give you 5 newtons. So on a normal day, if it was totally immersed, our upthrust will be what? 5 newtons. Please take note of that. If it was totally immersed, our upthrust will be 5 newtons. But they say it was partially immersed, so we can assume that it is only half of its volume that it's used to immerse. So all you need to do is to just divide this one by 2. So if we assume that half of volume was immersed, that implies that the upthrust here will now be what? 5/2, which is 2.5 newtons. So that is assuming that, so since they said that it was partially immersed and it was not fully immersed, the upthrust I got at first catered for when it was fully immersed. So we'll go for 2.5 newtons in that place. But what matters is you knowing how to solve the problem. So in JAM all, you'll see a much more detailed question. That's 33. Let's go to question 34. I really want us to be fast today. Please, just for confirmation's sake, I hope you guys are following what I'm doing and you are getting it. Please drop a comment. Let me know if you are following and you are getting what, and you are following the class. Also, there are only 4 persons in this life. There are only 4 persons on this life, and then almost like 15 or how many persons voted that we should do it by 8. Now it's 8 now. Most of them are not here. So please let me tell them that they should join. Oh, okay, it's cool. Thank you. By the way, please drop a message for me when we are done with the class. School, please drop a message for me when we are done with the class. 34 now. A force of 10 Newton is applied to a spring of spring constant, so we have a force. The force is 10 newtons, and the okay. So and then the spring constant gives us that's where is that 200 newtons per meter. 200 newtons per meter. So the question asks us that um respectively, what is the slope and area of the graph obtained when the forces are plotted against extension respectively? So in this case, this is a case of graph plotting. You see, when you plot graph, let's say I want to plot a graph now of force versus extension. Take note of this very well. Now, when you are dealing with slope, slope is always change in y over change in x, while area always take the form of change in y times change in x. Please take note of that. Slope always take change in y over change in x. Area always take the form of change in y times change in x. So in this place, that implies that I'm plotting f versus e. So I can easily get my e from this place, knowing that f equals ke from Hooke's law. From Hooke's law, since f equals ke, that means that 10 equals what? 200 times extension that was caused. So extension in this place will be 10 over 200, and 10 over 200 is 0.05. So the extension is 0.05 meters. So now let's now look at what we are looking for here. So the first case is slope. Slope will now be what? Change in f over change in e. So that's f over e. That's 10 over the extension is 0.05, which will give us what? 200. That's the slope. And for the area, that will be the multiplication of f and e, and that's f is 10, e is 0.05. So what would that be? That would be 0.5. That would be 0.5. So the correct answers to that question would then be 200 and 0.5 respectively. So that's the correct option there will be B, like that. That would be B. Okay, so let's move to question 35. Question 35. So the question says that a body of weight 6 Newton rests on a plane inclined at 30 degrees to the horizontal. What force keeps it from sliding down? So when you have this guy, so you have a plane. This plane is inclined at angle 30 degrees to the horizontal. So you have the body resting on the plane like this. So let's say this is the body, and the mass of that body. Okay, they've given us the weight. The weight is acting downward, which is 6 newtons. So they say, what force is keeping this body from sliding down? So is it a frictionless plane? Okay, that one does not really matter here now. So what force is keeping it from sliding down? So to be able to get that, the force must be acting upward. The force that will keep it from sliding down, that force must be acting what? Upward. So let's call that force F. So if it is force F, please I will don't forget, I will still always send the notes. So in case you need me to be scrolling up, just know that I'll always send the what's it called. So what is happening here is that you need to draw a sort of line, like a normal line in this place. You draw the normal line. So where this is the normal reaction. Normal reaction is always, why do we call it normal? Normal in physics and math means perpendicular. So normal reaction means that it's perpendicular to the plane. So if that is normal reaction, then you draw this angle here will always be the same thing as angle of inclination. Will always be the same as angle of inclination. So what we want to do now is that if you view this plane as your horizontal, then we will draw this thing out. So you see that if normal reaction is your vertical, so you draw your vertical lane, so your normal reaction is here, then the plane of the inclined plane is cutting it like this. So on the right, what do you have? F, and then just like this. So you have right here, you have the weight 6 Newton, and the angle is making this angle with the normal, that is 30 degrees. So in case you don't understand what I'm doing here, I'm just rearranging this thing so that I arrange it in the vertical and horizontal. So thank God I can easily rotate this to show you guys. So this is just like me rotating this. So can you all see? So you can see that now. So it's like I'm rotating this now. I'm now plotting it like this. That's exactly what is happening there. So it's just like a rotation of this. So you can see that N is going up, F is going to the right. Then you have 6 newtons going in this way, and the angle it makes is 30 degrees. So do we all understand that now? That's what I just did now. Please respond if you understand what I just did now, how I got this one on the right hand side now. So how I was able to get that, so is by just rotating that every other component. Okay, while I'm waiting for your response, let me just continue. So now what we need to do here is that we need to find the value of this force. So very good, very good, very good. So to keep it from sliding down, don't forget resultant force is always equal to MA. Resultant force equals to MA. I don't need anything about the vertical this time around because I only need to do with the horizontal. So with the horizontal now, I will have what? I will have on the right hand side, I have, now if the direction of motion is always the positive side, so and direction of motion is sliding down, that is the intended direction of motion. It was intended to slide down, so I can take this left hand side as the positive side now. So now here is one thing that you have also heard that is very, very wrong. You know that they always tell you that when the angle horizontal is always cosine and vertical is sine. You see, in this place, when you want to take the horizontal here, the horizontal component of this 6 Newton is actually 6 sine 30 degrees. 6 sine 30 degrees. And then the F is opposite it, that will be minus F. That will give us the total resultant force. And like you know, this thing will always be equal to MA. But because the object is not sliding down, it's not even moving at all, therefore there's no acceleration, this will be equal to 0. Please let me know if you all understand that sine 30, why I did for horizontal and I did not use cos 30, I used sine 30 instead. Please let me know if you guys understood why it is so, why it is not cos 30 even though I'm doing horizontal and it is sine 30 that I'm using instead. Do you guys understand that? Is that something that is clear to everybody? So I can just move on. Okay, you see, the thing about this is that actually if you guys had watched the video that I sent the link yesterday on the group page, you would understand resolution of vector. You need to know how to resolve vectors. And you see, what they forgot to teach you is that horizontal will always be cosine if the angle is made with the horizontal. You see, this angle here was made with the vertical, and I want to resolve this 6 Newton to the horizontal. See, whenever the angle you are dealing with is not made with the axis you are dealing with, you will always use sine of the angle. So you can see that in this place now, this is going to be sine because the angle 30 degree is what? Is with the vertical axis. However, the component I want to get is the component in the horizontal axis. So whenever you have such contradiction, in sense that you have your angle on the other side of who you are not even interested in, then you would always use sine to represent it. Go and watch that video that I posted yesterday. I mean, the link of resultant vector. You will understand this thing better. I had explained in detail there. So I'm going to move on. And so I believe that you understand, at least in a little way, why I'm using sine 30 and not cos 30 like you all have, wrongly known before. So in this place now, 6 sine 30 is 3 minus f equals to 0. And why am I equating it to 0? I think I've already explained that. It's because along this horizontal part, along this plane, there is no motion. The motion is 0 because they say that the body should not what slide down. We need force that will not make the body to slide down, and that means that if the body is not sliding at all, then it's not accelerating. Acceleration will be equal to 0. That's why I'm equating this thing to 0. And if you solve this very well, that means that the force required to keep this body from sliding down is a force of 3 newtons. So guys, let me know if that's clear now, so that I can proceed to the next question. Thirty-six. An object, we are a little bit slow. We need to solve plenty questions today, and I'm only on 6 questions. I want to see if I can even do up to 30 questions. Hopefully. I'm not saying we might be able to. So 36. We have the question says that an object of mass 300 kg and a density of 600 kilogram per meter cube. So we have the mass. The mass is 300 kilograms and the density of that same object is 600 kilogram per meters cube. So the question says that it was suspended with a spring so that half of it is immersed in paraffin of density 900 kilogram per meter cube. What is the tension in the string? Oh, this is a very easy question. So let's say this is our paraffin. Our paraffin is here. Then the object was immersed such that only half of the object was immersed inside the paraffin. So definitely this object is hanging by a thread, most likely. So let's say there's a thread here that this thing is hanging with. Then let me finish the thread. Now, so as it's hanging now, what I've already explained to you is that there is a weight that is acting downward. The weight is always acting downward. Then there will be tension in this string. However, because this particular guy is being immersed in a fluid, there will also be what we call upthrust. Let me use a different color for that. There will be upthrust. Upthrust will always act upward. Upthrust will act upward. So now I've given you the formula to find upthrust earlier. I told you that upthrust is rho Vg. Rho has to be the rho of the liquid. Then volume has to be the volume of the substance that was immersed. And G is, you know what your G is already. Now what is this weight? Is the entire weight of the object that is acting downward. That is the entire weight of the object that is acting downward. Since this object is kept in equilibrium, then what do we have here? We have that tension. Now, so what you see here is that to find your resultant force, according to what I've taught you, let me see whether you have been following me. To find resultant force, in this place we have 3 forces here. We have tension, we have upthrust, and we have weight. So guys on the same side, they will add up, and then anybody that is opposite them will be subtracted. So what do you think the net force in this thing will be in terms of T, U, and W? I want you to write it in the comments. In terms of T, U, and W, what will be the net resultant force in this system as we have it? So what will be the net resultant force in terms of T, U, and W? Very, very good, 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 very good. Yeah, makes sense. So you have T plus U minus W. That would then be equal to 0. Why is it equal to 0? Because there is no sinking. No sinking whatsoever. This thing is just hanging there. It's just going to feel that tension. So that is why it is 0. So once there is no motion, then you will equate it to 0. Or if the motion is done with uniform velocity, because uniform velocity always implies that acceleration is 0. So take note of those two cases. One is static equilibrium, the other one for motion, where there is motion but it's under uniform velocity. That one is for dynamic equilibrium. Okay, that's just by the way. So in this place now, you can easily get your tension. So let's first of all get our upthrust. Our upthrust will be rho, density of the liquid, which is density of paraffin. According to that question, density of paraffin is 900 kilogram per meter cube. So I'll just keep the unit. So 900 times volume of the substance that was immersed. Only half of it was immersed. Please don't make that mistake. So we were not given the volume directly, but with this information we can get it, knowing that density equals what? Mass over volume. That means that volume equals mass over density. What is that? 300 over 600. And what's that going to be? 300 over 600, that's I think that's 0.5. Yeah, so that's 0.5 meter cube. That's our volume. But don't forget, it is half of it that was immersed. So you have to divide this thing by 2. According to the question, only half of it was immersed inside the fluid. So so that is why that there is over 2, and multiplied by acceleration due to gravity, which is 10. So what is that going to be? So you have 900 times, so if you do all of these things together, that will be 9,000 times 0.5 divided by 2. So everything about the upthrust will give us 2250. And the weight of the object is also easy to get. We have the mass. So the weight of the object is mg. Weight is mg, which will be 300, so 3000 newtons, like that. 3000. So let's substitute everything inside. So that means that from here, T will be W minus U, like that, which will be what? 3000 minus 2250. I guess that should be 750 Newton. Yeah, so that is that, and that solves the problem. Okay, let's move to the next question. Question 37. Question 37. So we have a uniform beam 6 meter long and weighing 5 kg rests on support P and Q, placed left and right, 1 meter from each end of the beam. Weights of mass 10 kg and 8 kg are placed near P and Q, one on each of end of the beam. I like this question so much. It's a perfect question to explain everything that has to do with anti-clockwise or clockwise. So let's follow the question one by one, and then let's draw out the thing. A uniform beam, which is what? 6 meters long. So draw your uniform beam. So everything, the total length that we have here, 6 meters. Now, you see, what do we mean by uniform beam? Uniform beam definitely means that the weight is evenly distributed. So that means that the center of gravity will be at the center. So they gave us an information. They said that what? 6 meter and weighing 5 kg. So if it is weighing 5 kg, because it is uniform. If it is not uniform, we will not be able to do this. So because it is uniform, then the weight will be acting at the center. I think that's not centered enough. The weight will be acting at the center, and that weight is 5 kilograms. 5 kilograms. So from what we know, we'll convert the 5 kilograms to weight. That will be 50 newtons. That's the weight of the object. So you can see the way I'm analyzing the whole thing one step at a time. So that's the first force that will go there. Then they say they support it at points P and Q, placed left and right. These things are placed such that they are 1 meter from each end. What does that mean? That means that there is a pivot here and there is a pivot here. Why is it going inside? It's going inside because of that from left and right. So let's say this is our P and this is our Q. So they support it. They say that 1 meters from here, 1 meter, and also this one too is what, 1 meter. So you can see how I'm answering the question one after the other. Then they now put additional weight of mass 10 kg and 8 kg are placed near P and Q, one on each end of the beam. So they now come and place at the very end, they place at end P and Q, they place weight of 10 and 8 kg. One is near P, one is near Q. So near P they place a weight here, so the weight is 10 kg, which will be 100 newtons. Near Q they place another weight, the weight is 8 kg, which will be 80 newtons. That's what they have placed there. So in that case, I think we are done with the whole structuring and everything. So the question has said that calculate the reactions at P and Q. So I hope you all followed the way I analyzed the diagram. So you have to be able to analyze diagram as a physics student. So I will need more room up here. So hope you all followed what I did. Okay, so now they say we should find the reaction at P and Q. One thing you should know is that for every pivot, there is always going to be reaction. At every pivot, there's always going to be reaction. So let's call this one reaction at P, and let's call this one reaction at Q. So to solve this problem, you don't, I know people always care question that have two pivots. You don't need to care about it. It's not really a big deal. What you need to do is that you need to jettison one of the pivots. That means you need to forget as if, you need to behave as if one of the pivot is not there. So if you want to behave as if one of the pivot is not there, so to do that, this is what I'm going to do. I'm going to just, bring a little bit of a shady thing here. So let's say I want to forfeit that this pivot is not here. So I'm going to draw something of this nature. Okay, let me not stress by that. Now, please, I need feedback from you guys. Are you with me up until this point? So that I know that we are together. Please, I need your response. Are you all with me up until this point? Are you all with me up until this point? Please give your feedback if you are with me up until this point, because I don't want to be doing magic for you guys on the board. Okay, only one person has responded. Only one person has responded. I won't be able to wait that long. I will just continue, and then Chidera, what part are you confused about? Please, what part are you confused about? Is it the diagram or a particular part of the diagram? Okay, so for the diagram, I'm just going to brush through it just a little bit. So if you look at the diagram very well, if you look at the question says that there is a uniform beam. That beam is the one I drew from here to this end. Please pay attention. That uniform beam is 6 meters long. Then they proceed to say that this 6 meters long beam has a weight of 5 kg. That means that weight will be 50 newtons, like that. So for uniform objects, their weight is always at their center. It's always acting at their center. It is not always so for all kinds of objects. It is only so for uniform objects. So hence, I placed the 50 newton at the center. Then if you further read the question says that it was balanced at point P and Q with so they place support. Support is like a pivot. So, but those pivots, they are not directly at the end of the beam. The way they said in the question is that what? They are 1 meter from each end. That means that you have to move 1 meter inward to get to P, and you have to move 1 meter inward from right to get to Q. So that is how I got the whole 1 meter thing. So I believe that makes sense. Now, the next thing after that was that they now added external forces These external forces, one is weighing 10 kg, another one is weighing 8 kg. Now 10 kg will become 100 newtons and 8 kg will become 80 newtons. So the 100 newtons ohm was placed close to P and the 80 newton ohm was placed close to Q. So in this case now, we place 100 newton and they are at the extreme end. So please make sure you are reading the question so it will help you understand what I'm doing. So one is close to P and the other one is close to Q. So I place that there. So after doing that, now so that we should find the reaction at P and Q respectively. You see, reaction, for everywhere there is pivot, there will always be a reaction, and reaction is always upward. So that is where I got all these guys from. So does that make sense to you now? I think it should make sense to you now. So let me go to the solving of the problem properly. Now, to solve the problem, whenever you have two pivots, in fact, you can have three pivots, it does not really matter. What you need to do is that you need to assume that it's only one pivot you have. And you can actually choose any of these pivots. So let's say, for instance, now, let's say, okay, good one, Chidera. Now, let's say I want to pick this pivot. So everybody, you want to actually pay attention here to what I'm going to be doing here. Now, if I'm picking this pivot, then I will forget this pivot Q. I will assume that that pivot Q is not there. And I'm going to take clockwise moment and anti-clockwise moment. So this is what I'm going to do. I'm going to say clockwise. I will write that one here. And I will write anti-clockwise. I will write it down here. So I will now identify each of these guys. So let's look at how many forces are acting in this system. We have force 1, force 2, force 3, force 4, and force 5. So I have to analyze each of these 5 forces. Then each and every one of them, I'll be analyzing them around this pivot to determine which one is clockwise or which one is anti-clockwise. Now this is how I always teach my students. So what you want to do here is that if this pivot is what you are taking the moment about, don't forget, by the way, moment is force times perpendicular distance. Force times perpendicular distance. That is, for instance, now this 50 newton, you must be able to get the distance from this 50 newton to this place. This 100 newton, you must be able to get the distance from here to the pivot. This 80 newton, you must be able to get distance from here to the pivot. I mean, you need that distance. So let's now go now. The first thing I want to analyze is 100 newton. So this is what you do. Your hand can guide you in this place. So see the way I'm going to be using my hand. You will assume that you are using one of your hand to hold the pivot. Then the force I want to consider is force 100 newtons. So when you notice this force 100 newtons, if I hold down this place and I pull 100 newton, how do you think this table will turn? You see the way it's turning? Can you guys tell me how it is turning? Please, I need your response. If I'm using my finger to hold the pivot down and I'm acting on this 100 newton, in which direction is it moving? Is it clockwise or anti-clockwise? Look at the way it's going down like this. Will it be anti-clockwise or clockwise? Don't forget, clockwise is the way your clock always works. Anti-clockwise is the opposite direction. So that 100 newton, is it clockwise or anti-clockwise? Is it clockwise or anti-clockwise? Okay, good one. Very good. So now that means that this is where I will place it. That will be 100 multiplied by, very good, well done guys. So what's the distance between this and this? That's 1 meter according to what I've analyzed before. So that's 100 times 1. So I will go again. I will go to the second force. In fact, we can establish here that if you do the same process, you hold this guy now, you know that this one will move clockwise, this one too will move clockwise. So that's settled. So that will be 50 times. Now, what will be the distance from here to this place? This one is very trickish. I told you the other time that this thing is, the weight is acting at the center. That means that from here to this place is 3 meters. 3 meters. Yes, because the whole length is 6 meters. So from the edge, extreme edge to the middle is 3 meters. But what we notice is that 1 meter is already taken from here to the pivot. So what will be left in this place out of the 3 meters? What will be left will be what? 2 meters. So that will be 50 times 2 plus. Now for this other one now, 80 newtons, total length is 6 meters. The pivot is already taking 1 meter. That means that whatever is left from here to this other end where 80 newton is going to be very good, very good. Well done, well done. So this one, the rest is going to be 5 meters. So that will be 80 times 5. But I'm not done. I've just analyzed 3 of the forces. Now let me go and analyze the fourth force, the fourth one now. So for the fourth one, we will have so let me, for the fourth guy, which is RQ. So RQ, the distance between RQ and the pivot here, RQ and the pivot. And also let's analyze our RQ. I want you guys to tell me where it will move. So if I place this guy, I pin it here, you can see RQ. RQ is being pulled up. So how will it turn this table? How will it turn it? See the way it's turning it? Which direction is that? So to save time, that is anti-clockwise direction. So that means that whatever RQ is, that is plus R at Q multiplied by the distance from here to here will be 4. Why? Because 1 meter is already cut out here, remaining 5 meters. Another 1 meter cut out here, which means that what will be left between the two of them will be 4 meters. That is how I got that. So it will be 4 meters. Now, the thing about reaction at the pivot is that, very good, well done. Reaction at the pivot cannot be resolved, because guess what? What's the distance? This guy is at this point. The distance between this point and this point is still 0. So you ignore. So for any pivot you are dealing with, you will ignore the reaction at that point. So we are done with that. The rest, the RP will be 0. So because it is exactly at that pivot. So now, once we are done with this will now be 50 times 2 is 100. 80 times 5 is 400, and that's 500. Then this will be, so 500 newtons meter, by the way. Then this is 100 plus 4 RQ. Now in this place, now what happened is that sum of clockwise equals to sum of anti-clockwise, and that definitely implies that 100 plus 4 RQ will be equal to 500, which implies that if you solve this quickly, your R is going to be 100, RQ rather is going to be 100 newtons. If you solve that very well, your R is going to be 100 newtons. Now we don't need to go through this headache to get our RP. Now sum of upward forces must be equal to sum of downward forces. Sum of upward equals to sum of downward. So what are the two upward forces that we have? Those are RP plus RQ must be equal to sum of downward force. Downward force that we have 100, we have 50, and we have 80. What does that imply? We already know our RQ. That means that RP plus 100 equals, so when you do this whole whatever, this should be 230 here, and that implies that RP will be 230 minus 100, which is 130 newtons. So hence reaction at P is 130 newtons, while reaction at Q is 100 newton. That one really took our time. So yes. Next question, question 38. Okay, for those that are still copying, but I'll still send the note anyways. So question 38, we have in X, we have which of the, so let's solve X first. X says that which of the following quantities has dimension ml2 t raised to power minus 3. So basically, to get this one, what you want to do is that you want to know that capital M is for kilogram, capital L is for meter, and capital T is for seconds. So that means that the unit that we are dealing with in that place, according to that now, is, so when we have a dimension of ml raised to power 2, t raised to power minus 3. So this guy is kilogram meter squared per seconds cube. Kilogram meter squared per seconds cube. So you can easily delete some things. Acceleration, density, it is neither of those guys. So your option lies between power and work. So let's look at the unit of power. Let's even look at unit of work in the first place. Work is energy, which is what? Force times distance. Force is kilogram meters per second squared times distance is meter. So that means that work will be what? Kilogram meter will now have power 2 like that. Seconds raised to power minus 2. Automatically, it cannot be work because work has s to minus 2, while this one that we're given have s raised to power minus 3. So lastly, let's try power. Power is basically work done over time. So since we have been able to get that of work done as kilogram meter squared s raised to power minus 2, time is down here, so we have s. When you do your indices, you have kilogram meter squared s raised to power minus 2 minus 1, that will be minus 3. So hence that thing belongs to power. That thing belongs to power. So A is the correct answer for A, and sorry, for X. For the Y part of the question, which of the following are vector quantities? So every one of them are vector quantity except for work. Only work is not a vector quantity there. So the correct option for that is option C. Option C is the correct option. So to now answer question 38 now, that says that to the answers to the question X and Y respectively, they are A and C. A and C. So the correct answer for 38 is option C. Option C, like that. So A and C. Let's go to question 39. Question 39. So what we have in question 39, a student pulls his toy on a smooth horizontal surface with a rope inclined at 60 degrees to the horizontal. If the system is in equilibrium by the weight of the toy and the tension in the string, with the effective force pulling the toy along the horizontal being 5 Newton, then the tension in the string and the weight of the toy are respectively. So now, the reason why the object is still being pulled and is still in equilibrium is that it is a dynamic equilibrium. So let's draw a sketch. So we have this. Let's say we are placing the toy down here. So let's put the toy down right here. So then this person is pulling at an angle of 60 degrees. So there's a tension in this string like that. There is a tension. Now, and it's on a smooth horizontal surface, meaning that there is no friction. That's what that means. So the weight of the object will be acting downward. Weight will be acting downward. Let's call that mg. I've told you where there is weight, there will be what? Normal reaction. There is normal reaction. So from there, what do we have? What other information do we have? The effective force pulling the toy along the horizontal being 5 Newton. What they mean by this is that the net force along the horizontal is 5 Newton. That means that our resultant force is 5 Newtons. Our resultant force is 5 Newtons. So this has made life very, very easy for us like that. The question is asking us to look for the what? The tension and the weight of the object respectively. So this is quite easily done. So what we need to do now is that, do we have any other information I've not imputed in this thing? I do not think so. Student poses blah blah blah, weight of the boy and the tension. Okay, the effective pulling the toy along the horizontal being 5 newtons, then the tension in the string. Okay, so this is already like I said, this is already very easy. On this horizontal, the only person that is pulling is T. So the component is T cosine 60 degrees, which is equal to what? 5 newtons. Why is it so? Is because in this horizontal, only the tension has horizontal component, and the angle 60 degrees is made with the horizontal. Hence, the resulting will be what? T cos 60 degrees. So that means that the tension is 5 over cos 60 degrees. And cos 60 degrees is 0.5. So when we do that, so this will be 10 newtons. So we have been able to get um the tension like that. The tension is 10 newtons. So now the next thing we want to get is that we want to get the weight of this object. To get the weight of the object, we have to do a little bit of math. So first is that the tension, will do vertical resolution. In this vertical resolution now, there are three different forces acting. We have the normal reaction acting upward, we have the weight acting downward, and we have the tension in the string acting in this manner. So from this place, they did not give us enough information so along the horizontal, but let's see. So let's resolve in the vertical direction. In the vertical direction, so n is moving upward, so that's n, plus tension is also moving upward. When I want to resolve now, that will be what? T sine 60 degrees, then minus what? Minus the weight, which is acting downward, will be equal to 0. Why is it equal to 0? There is no motion in this place, in this vertical direction. The body is not moving up and the body is not being pressed down, so automatically this is the case. And we already find our tension, so that means that n plus 10 sine 60 degrees minus w equals 0. So that implies that 10 sine 60 degrees, if you do that very well, 10 sine 60 degree will be approximately 8.7 minus w equals to 0. So that implies that n plus 8.7 equals w. So our w equals to n plus 8.7. So now we might be tempted to say that, oh, this place we want to squeeze everything inside and just say that it is 8.7. According to this question, the student was pulling the toy on a smooth horizontal surface with a rope inclined at 60 degrees to the horizontal. If the system is in equilibrium by the weight of the toy and the tension in the string. Okay, find the effective force. So now, the statement that was said that the system is in equilibrium by the weight and the tension in the string, please take note of that. It means that they are trying to neglect the effect of this normal reaction. On a normal day, when you are analyzing a problem like this, you should always have normal reaction. But this question is saying that the only thing responsible for making this thing to be in equilibrium is what? Is the tension in the string and the weight of the object. Meaning that the weight that is acting downward and the component of the tension that is acting upward keeps this object in equilibrium. That is, we don't need to bother about the normal reaction. So that is what that means. So I just intentionally did the general way, so then which will help you to solve other problems. So if I assume that n equals to 0 here, that implies that the weight of the object will be 8.7 newtons. So that means that the correct answer in that place is A. The tension in the string is 10 newtons while the weight is 8.7 newtons. So that is the correct answer to that question. Okay, that was question 39. So I think we can move to question 40. There's no problem. We can move to question 40. Please know that you can still ask your question. Once I see it in the chat, I'll be able to respond to you. Okay. You are given the atmospheric pressure. Atmospheric pressure, PATM, was given as 13 times 10 to the negative, no, sorry, 13 times 10 raised to power 5 newtons per meter squared. Then followed by what other information were we given? Like, what is the, so height, depth, 10 meter, depth, we're given 10 meter deep. If the density of water, of the sea water, sorry, of water is 1000 kilogram per meters cube. So they want us to find the pressure at the bottom of an ocean, which is 10 meters deep. So this is a very simple question. Total pressure, note that total pressure is PATM plus or minus gauge pressure, which is rho GH. Gauge pressure is rho GH. Now, when do we use plus? When do we use down? And when do we use minus? You use plus when you are dealing with depth. And you use minus when you are dealing with height. That is, you are going up above sea level. Then you use what? Height. So now, in this case now, we are going to use what? Plus. So we're going to use plus because since we are going below the sea level. So the total pressure in that system will then be what? 13 times 10 raised to power 5 plus density is 10 raised to power 3 already, multiplied by gravity is 10 and the height is 10 as well. So that's 13 times 10 raised to power 5 plus 10 raised to power 5. So basically 10 raised to power 5 is common. So that will be what? 13 plus 1 times 10 raised to power 5. So what I did here is that 13 times 10 raised to power 5. This thing is the same thing as, so I can write this also as 1 times 10 raised to power 5. It doesn't change anything. So if you factorize the 10 raised to power 5, when you want to add stuff like this, you make sure that they have the same power of that exponent of 10. So with that now, you have 14 times 10 raised to power 5 Newton per meter squared, or pascals, depending on the units that they want you to find. But you can convert these things to standard form. That will be 1.4 times 10 raised to power 6 pascals. So 1.4 times 10 raised to power 6 pascals. So that's the correct answer to that question. Let's move to question 41. For question 41, we have a metal ball is thrown vertically upward from the top of a tower with an initial velocity of 20 meters per second. If the ball took a total of 6 seconds to reach the ground level, determine the height of the tower. So this is a very simple question. So let's say we have the tower. So we have the tower in this place, and the boy is standing on the top of the tower, then threw a ball. So the ball will take this part and then come to the ground. So they said the total time it took was 6 seconds for the ball to get here, and the initial velocity with which he launched, the initial velocity was 20 meters per second. So it launched with an initial velocity of 20 meters per second. So with that, with all this information that we have now, that's question 40. Yes, question 41. If the ball took a total of 40 seconds, what is the height of the tower? So we are looking for this h, the height of this tower. Actually, we can use so many information in this place. We can use a lot of information. But the way we can analyze this thing is that we can break the whole motion down into two phases. First, we can break it into phase of when it was first going up, and then when it now starts coming down. If I can get all of this information, then everything I need is already okay. So guess what? We can get the time it took to go up. So analyzing the up part of the motion, please pay attention. Analyzing the up part of the motion. So what we can denote from there is that our initial velocity was 20 meters per second. And we don't know the time it took to get up. Then we can denote also that our final velocity is 0. Why is it 0? You see, when an object, there are two conditions for an object to stop moving. Number one is if the object should hit a barrier. That is, Look at this my pen now. This my pen can continue to move, but it has to stop once it reaches my screen. That's one condition. Secondly is that if I launch the object, if the object has already exhausted its velocity and the source that was responsible for the motion in the first place is no longer there, then the object will also stop. So the reason why the object could not go up again is that there was a momentary stop up here. So in terms of the upward motion of this guy, the final velocity was 0. See, final velocity can be 0. I told you yesterday or day before yesterday that initial velocity is not always 0. What makes a velocity to be 0 is if a body is at rest. Is rest velocity that is equal to 0. So what do we want to do now is that, so I've analyzed that. We know that we'll use our G. Our G is 10 meters per second squared. So with this now I can get my T using, when another thing. When an object is going up, your equation of motion becomes this. When it is going up, this is what your equation of motion, this is what it becomes. V equals U minus GT, then V squared equals U squared minus 2GH, then H equals UT minus half GT squared. Okay, the reason why I'm not using 6 seconds is that 6 seconds, according to the question, is the total time for the journey. Total time it took for it to go up here and come down here. That's the total time it took. So that's not the time it took to go up. Now I've broken the motion down into two phases, the phase where it went up and the phase where it is going down. So I've broken the motion into those two phases. So I don't know the exact time it took to go up. So is that clear now? Do you understand that now? Okay, very good. So now when you are coming down, the equation carries its positive as usual. V squared equals U squared plus 2GH. H equals UT plus half GT squared. So in this case now, as we are going up to use this equation, I will then have V equals, so using V equals U minus GT, my V is 0, equals U is 20 minus 10t. That means that minus 20 equals minus 10t, meaning that t will be equals to what? 2 seconds. So with that now, I've gotten the time it took to go up. Time it took to go up is 2 seconds. What does that leave me with? That left me that the total time it took here is 4 seconds. The total time it took there will be 4 seconds. And then I can work with that. So don't forget, let's now analyze the down motion. So the down motion now. For the down motion, what can we tell? Initial velocity will be 0 meters per second. Why so? The reason it is so is because the final velocity of the first phase of the motion will be the initial velocity of the new phase. So whatever ended one is starting the other. So as it was final in the first case, then it is initial for the falling down motion. Then what do we have again? We have t equals this. T equals 4 seconds for the falling down motion. T equals 4 seconds. Where did I get that from? If going up took 2 seconds, total time is 6 seconds. That means that it will use the remaining time to get down. Now, these two information we have, we still have our G. Now, these three information we have, U, T, and G, we can use it to get plenty things. And then one of the things that we can use it to get is height. That is the height it has fallen through, the height from this top to this place. That's one of the things we can get. But that would take me a lot of time if I want to use that approach. What I want to use here is that I will use the approach of energy conservation. So what is energy conservation? It's simply that energy is conserved such that total mechanical energy here at the top here will be the same thing as total mechanical energy down here. In fact, let me quickly digress a little and use that opportunity to teach you something. Total mechanical energy is kinetic energy plus potential energy. Now, at some point, total mechanical energy will be purely kinetic, while at some point it will be purely potential energy, and at some point it will be a mixture. Now, what is kinetic energy? Kinetic energy is possessed when a body has speed. Kinetic energy is possessed when a body has speed. Also, what is potential energy? Potential energy is possessed by virtue of position. Potential energy is possessed by virtue of position. So now, in this case now, so I want to ask you questions now. So let's analyze this whole thing. At this point of throw, can you tell me, does this thing have kinetic energy only, potential energy only, or both kinetic energy and potential energy? So I need an answer to that question. So does it have kinetic energy only at point of throw? At this point of throw A, does it have only kinetic energy? Does it have only potential energy? Or does it have both kinetic energy and potential energy? So if it is only kinetic energy, type K. If it is only potential energy, type P. And if it is both, just type both. So I want to know whether okay, nice. Only one person has been responding to me. Oh, okay, very good. Oh, Chidera, you're still here. Very good. Very good. It has both. Nice one. So now let's now take the rest are not answering. I hope the rest are following this class. Now let's now look at this point. Now this point is very, very tricky. This is the point just before it hits the ground. The point just before it hits the ground. So what do you think will happen here? Will it have both or only one of them? And which one, if it is only one of them that it will have? So please, which one will it have? At the point just before reaching the ground, what will it have? Both, only one, and if only one, which one? Don't forget, potential energy is the energy by position. Potential energy is only energy by position. Okay, well, I see where you guys got it from now. If you notice that at this point I just indicated now, this point is at zero height above the ground. So because of that, it cannot have potential energy, because if you want to have potential energy from the ground, you must be going up. Like you must be at a particular level, at a particular height above the ground. So what will happen is that this object is falling down, up until this point. So as it fell to this point, before it touches the ground, it will still have a maximum velocity. So in this place, it is purely kinetic energy and no potential energy, because it is a point just before this thing fall to the ground and the ground now stop it. So if it is not at the height above, it cannot have gravitational potential energy. So do you understand why it is not potential energy now? Why the correct answer is kinetic energy? Do we understand that now? Okay, very good. So, and to get kinetic energy, what do I need? I need V. I need V. So that means that I should not waste my equation here. I should use this my parameter to get my V. So that will be V equals U plus GT. Since it is coming down now, that will be 0 plus G is 10, then 4. That will be 40 meters per second. So I have my V. So using the conservation of energy, so total energy at the top there, which is mgh, so ke, so let me call this place point B and that point B. So K at A plus P at A will be equal to what? K at B, since there's no P at B. So let's now get those things one after the other. So K at A, kinetic energy is half mv squared. So I don't think we were given the mass of the ball. Where is that question again? Okay, mass. So let's just assume that it is mass m. Then v squared, that will be 20 squared at A. Then plus potential energy at A, that's mgh, m times 10, that's the height. The height is the height of the tower we are looking for, equals kb. We have already gotten the velocity down here. That's half m. Our v is what? 40 squared, like that. So in this place, what do we have? So if you do this very well, 20 squared is 400. 400 over 2 is 200. So that's 200 m plus 10 mh equals 40 squared is 1600. So that's 800 m. What you notice here is that m is common, so I can have 200 plus 10h times m equals 800 m. So m will cancel out like that. So as m has cancelled out, I now have 200 plus 10h equals 800. That means that 10h equals 800 minus 200. So h will now be 600 over 10. So that will be 60 meters. So the height is 60 meters. By the way, don't be scared by these my questions. Jam questions are always easier and simpler. The reason why I structured these questions this way is that it helps me to be able to teach other things exhaustively. For this whole thing that I've embedded in one question like this, now they can use it to form 5 questions for you. So now I've been able to use this opportunity now to teach you something more elaborate. That's why these my questions seem a little bit cumbersome. So but if you follow very well, you see that you would end up learning a lot of other things while we are solving one problem. Okay, so I'm going to move on to question 42 like that. So question 42, it says a U-tube contains some mercury of relative density 13.6 and kerosene of relative density 0.8 poured into one arm of the tube until the height of the mercury in that arm is reduced by 1.2 centimeters. Calculate the height of the kerosene. So to do this question now, so what we need to do is that we have a U-tube. This U-tube is always used in measuring relative density. Yeah. So first of all, there will be a down layer here. Then the first thing that was contained inside the U-tube is mercury. So mercury was at this level. Then when they now pour kerosene inside here, so they pour kerosene randomly here. So we are looking for the height of this kerosene. But in that situation, the height of this guy has reduced by how much? By 1.2 centimeters. The height has reduced by 1.2 centimeters. So how do we go about this particular problem? So what we need to do is that we need to know that pressure in both ends are always the same. That is why rho, okay, this one is mercury, this one is kerosene. Rho of mercury times G of G is always constant. Then rho GH of mercury will be rho of kerosene times G, then H of kerosene. G will cancel G, so we have rho M HM equals rho K HK. So for this particular question now, so what were the things that we were given? So we're given the relative density already. So relative density is always the one that we use as our density in this place. Relative density 13.6 and kerosene of relative density 0.8 is poured. So we have our density. So what we are looking for is the height of the kerosene. We are looking for the height of the kerosene. So since this guy was reduced by 1.2 centimeters, so what we have in this case now will then be, so we have density, which is 1 point, no, density for this guy was given as 13.6. So 13.6 So to get the correct thing now, so the height of kerosene that was lifted upward in that place, calculate the height of the kerosene. So to do that, we just slot everything inside. So we have density equals 13.6 for mercury times this thing was 1.2 centimeters. 1.2 equals density of kerosene is 0.8, height of kerosene. If you solve this very well, you get 20.4. Was it in centimeters that we were given? Yeah, you get 20.4 centimeters, like that. You get 20.4 centimeters. So that is what that would look like. So please hope we are still together. All right, since we are still together, so I'm going to continue. We have a uniform meter rule. So that's question 43 now. A uniform meter rule of weight 1 Newton is pivoted at 40 centimeter mark. A weight 2 Newton is hung at the 15 centimeter mark. Where must a weight of 2 Newton be placed? You see, this question, I will give you the best formula to deal with it. The best formula to deal with it is the formula of center of mass. So the center of mass is always where this thing will be balanced. So where must it be placed to balance the meter rule? That's what the question is asking for. So the uniform meter rule, first of all, has a weight of 1 Newton and is pivoted at 40 centimeter marks. That's where the pivot is. So wherever the pivot is the what's it called? The pivot is the center of mass. So center of mass, formula for center of mass equals summation mi xi over summation mi. What does this thing mean? I will quickly give you now. Center of mass in this question will be the place where that thing is marked, that pivot is. So the pivot is at what mark? Pivoted at 40 centimeters. So this thing is 40. Equals, now what is the meaning of summation mi xi? Is simply the distribution of the weight times their distance. So you can say the weight of the object is 1 Newton, and since this guy is uniform, I've already told you that any uniform body will always have their weight at the center. This uniform meter rule is of 100 centimeters long, so that means that the center will be what? The center will be 50 centimeters. So you have 1 times 50. So x is the 50, 1 is the m. So it could be mass and it could be weight. Anyone would work out. So why is it now summation is that there will be more than one there. So plus, let's look at another guy that is there as well. Is the 2 Newton guy hung at 15 centimeters. So another 2 Newton hung at what? 15 centimeters. Plus, they now want to hang another 2 Newton. They are looking for where to put it. let's call it x, then over summation mi, that is addition of all the masses here, which is what, 1 plus 2 plus 2. So with this equation now, we can solve the problem and we'll be able to get the mark, although I will show you how to draw it, how to use the diagram to solve it as well. So this will be 50 plus 30 plus 2x everything over, this is 5. So when you do this very well, you have 2x plus 80 equals 5 times 40 is what, 200. Hence 2x equals 200 minus 80 is 120. So x equals 60 centimeters mark. 60 centimeters mark. So that's the correct answer. But if you want to use the diagram method, you draw a diagram, everything is 100 centimeters, a uniform meter rule. Like I've taught you already, the weight, which is 1 Newton, will be acting at the center. The pivot was placed at 40 centimeter mark. So the pivot, so here is 40 centimeter. What does that make this one to be? 10 centimeters. Then they place somebody at 15 centimeters. So let's say that's somewhere around here. From here to here is 15 centimeters. Then you're asking you, where will they put 2? Where will they put 2? You see, the way this thing works is that you need to find the mark where you want to put the 2. And then, to not stress yourself, you can decide that you want to put the 2 here at a certain mark. So let's call that mark X. Now, if I call that mark X, that will now be that I will put 2 newtons in this place. Then 2 newton is here. So resolving around the pivot, we see that there's only one anti-clockwise, which is 2 times the distance from here to here will be, this place to this place is already 15. Then this place to this place, everything is 40. So 40 minus 15, that's 25. So this is 25. So the anti-clockwise is 2 times 25 equals, in this situation, we have 1 from this pivot is 10. So we have 1 times 10. Plus finally, we have these 2 newtons multiplied by this mark X is away from this place in such a way that the pivot already has 40 centimeter carved out. So that means that whatever is left from here to here will be what? X minus 40. And that will be 2 times 25 is 50. This is 10 plus 2x minus 80, like that. So when you do this now, this will be 2x minus, so 2x minus 10 minus 80, that's minus 70. So that means that this is 50. So when you take this to the right side, 2x will be 50 plus 70, which is 120. So x will be 60 centimeters. So you can choose the one that you like. Which one do you prefer? The first method I used or the second method that I used? You know, the second method can be a little bit confusing. Yeah, cool. So the second method, you have to do plenty analysis. Okay, let's try to be fast. No matter what the time is, I want us to cover, like, okay, somebody said they prefer the second method. Well, anyone is okay as long as you understand it. Okay, 44. I want us to see if we can solve before 10, if we can solve up to 60, up to that number 60. So let's see. I will be fast now. I think I'm dragging this thing too much. A body of weight 5.9 hangs from the free end of a piece of wire whose other end is fixed at the rigid support. A horizontal string, so let's start. So the body is hanging from here. So the weight of the object is always acting downward. So 5.9 Newton weight. So it has a weight of 5.9 newtons. No, I mean, like, get to question 60. We can. Some of them are actually very, very simple questions. So I will just try. But I want us to stretch it further, because exam. Some people have exam on Thursday. Some people have exam on Thursday, and if we are going at the pace at which I'm going like this now, as at which we are going, we realize that today is Sunday already. We are going to, let's say we get to question 50 today, and then we have Monday, Tuesday, and Wednesday. That's additional 60 question. That will only be around 1 hour and 10 question altogether, which we have 170 questions to go. And sorry, we have 170 questions in total. So let's see. It seems we are still going to be able to like do something. Okay, let me just continue. Even this time save, I'm already wasting it. Okay, we have this 5.9 Newton. Then a horizontal string attached to the body exerts a force which keeps the wire at an angle of 30 degrees to the vertical. So basically what's happening is that somebody now came to apply wire now in this direction. So it will deform this guy. In what manner? This is the way it will be deformed. It will deform like this. So you have this thing deformed like this, because somewhere is, so there will be tension in this string, there will be tension here. They now say that this thing makes an angle of what? 30 degrees with the vertical. So of course the weight is always acting downward. We still have 5.9 newtons here. So the question asks us to find, the tension is not the same because they are not the same string now. Let's call this one T1 and let's call this one T2. So the question is that the tension in the string and the tension in the wire are, so the string is this one. So let me call that one TS. And this is the wire. The wire is here and this is the string. See, I'm going to teach you how to solve this problem without racking your head. I always use these three methods. I always say fix one, extend another, fix, operation fix, extend, and reposition. FER, fix, extend, and reposition. So I want you all to follow the way I'm going to do that. Fix, extend, and reposition. So what do I mean by fix? Fixing means that we have three things here. We have TW, T3, and we have 5.9. So to fix means that let one of them remain the way it is. So the best one to always let remain the way it is the one that has the angle interacting with it. Is the one that has the angle interacting with it. Always fix it. Now, what do I mean by, so do we get the fixed part? I think we get the fixed part. So extend means that you pick, after you have already fixed one, I'm fixing TW now, since it's the one that has the angle interacting with it. But like, it's not still necessary anyways, but it's always easier to fix the one that has the angle interacting with it. Now, when you have fixed it TW, the next thing is extend. You pick either T3 or 5.9. The meaning of that, as you can see, the arrow is acting to the right. So you extend it to the left. You extend it to the left. So that is what extension means. If it was 5.9 we want to extend, you have to draw the arrow to go up. So now the last thing is reposition. Reposition basically is telling us that just go and carry the last guy and come and join body with the two guys that you have worked with. What you will notice is that that thing will form a triangle. So as it has formed a triangle now, so what do we notice? In this place, we have TW. In this place, we have T3 because that is what you just extend. And the one that you reposition that came here is 5.9. And what's the angle that is between them? 30 degrees. So that is it. Please let me know if this fix, extend, and reposition, let me know if it makes sense to you like that. What I did there, fix, extend, and reposition. Does it make sense to you? Okay. So now you can use SOHCAHTOA. You can use SOHCAHTOA to solve this problem. So if I want to use SOHCAHTOA to solve for TW, I can use cosine. Okay, very good. So very good, very good. So cosine of 30 degrees is adjacent. Adjacent is 5.9 over TW. That means that TW will be 5.9 over cos 30 degrees. So that's 5.9 divided by cos 30. So that is 6.8, approximately 6.81 newtons. Then that implies that we can use sine 30 degrees will be t string, yes, t string over tw. So which implies that t of the string will then be tw sine 30 degrees, which is 6.81 sine 30. So 6.81 sine 30. So that's 3.41. So the tension in the wire, so the question says that we should find the tension in the string and in the wire. So TS is 3.41 and TW is 6.81. So the correct answer is A. Yeah, A. Okay. I'm moving on now. Moving on. So I'm not going to, waste too much time again. I think I explained too much. So revolution, blah blah blah. So just know that period T is time taken over number of revolution, and frequency is always 1 over period. So this question is very easy. What is the time taken in this place is 15 seconds. How many revolution? 60 revolution. So you have 16 divided by 60. Sorry, 15 divided by 60. That's 0. So the period is 0.25 seconds. Why the frequency will now be 1 over 0.25, which is 4 hertz. So that question is very, very straightforward. It's a very simple question to solve. Just note that formula. So let's move to question 46. A wheel and axle is to raise a load. Load is 500 newtons. Then application of effort. Effort is 250 newtons. Then if the radii of the axle, so we have R to big R. Big R is 0.4 centimeters and small r is 0.08 centimeters. So respectively, what is the efficiency of the machine? So we need to get the mechanical advantage, which is load over effort. 500 over 250, that's 2. We need to get the velocity ratio. Velocity ratio is big R over small r, which is 0.4 over 0.08. So we have 0.4 divided by 0.08, and that's 5. So our efficiency will now be MA over VR times 100%. So that's 2 over 5 times 100%. So this goes here 20. So the efficiency of the machine is 40%. 40%. So I know I'm not too fast. So Roman figure 1 in this place. Roman figure 1 says that a body slides down on an inclined plane with coefficient of friction of 0.35 and the plane make an angle of 30 degrees with the horizontal. A body moves along a circular path with uniform angular speed and that the acceleration down the plane in 1 and acceleration towards the center in 2 are respectively. So in this place now we have a body sliding down. So the inclination is at angle what? Angle, where's the question again? 30 degrees. So the body is sliding down. So it's sliding down, and then the coefficient of friction is 0.35. So if it is sliding down, then friction must be opposing it. So friction always oppose motion. So this is the frictional force, and then the weight of the object is going to be acting like this. So what's the weight, what's the mass of the object that we were given in the question? A body slides down. We were not given the mass of this body, so let's call it mg like that. Then the frictional force is here. So I told you there will be normal reaction, and then this goes down like this, and this place will be 30 degrees. So if we turn this thing, it will look like this. Normal. Then we have here, we have no, that's not that side. Here now it is here. Mg, so permit me to call it 10m since g is 10. So on this side we have the frictional force and we have the normal. So that's everything we have in that system. So along the horizontal, okay, the angle is 30 degrees. Along the horizontal, I have 10m sine, I've explained this earlier, sine 30 degrees minus fr equals, so the what we are looking for is the acceleration down, so equals ma like that. So let's keep that now. So but I can simplify this further. Sine 30 will be 0.5, so that will be 5m minus frictional force equals ma. So however, I can do for my vertical. For vertical component, this will be n is going up minus 10m cos 30 degrees will be equal to 0. Now, where did I get that from? N is going up, 10 has a vertical component opposite it, fr is directly horizontal, so it will not have a component in the vertical. And then because the angle is made with the vertical, that's why I'm using cos 30 degrees. So that means that n minus 10 cos 30 is 5 root 3. 5 root 3m equals to 0. That implies that n equals 5 root 3m newtons. Now we know that frictional force is mu times normal reaction. Frictional force is mu times normal reaction. In the question, we have been given our mu. Our mu, which is the coefficient of friction, is 0.35. So multiply by 5 root 3 m newtons. That will give us, I think it's high time I convert this thing to decimal. 5 root 3 times 0.35. So that's approximately 3.03 m. So our frictional force is this. So I can go and substitute that into my very first equation. So this equation right here becomes 5m minus 3.03 m equals ma. So this already makes sense for us. 5m minus 3.03 m, so 5 minus 3.03, so that's 1.97. So 1.97 m equals ma. So divide both sides by m, so that means that acceleration is 1.97 meters per second squared. So please quickly give me feedback if you understood this thing I just did here. In the second case, you were given angular speed. Angular speed is 0.6 rad per seconds, and you were given linear speed. Linear speed was given as 3 meters per second. Now, oh wow, no, please let me know which part got confusing. I think you guys should have caught my attention to it the moment it started going wrong, because now I don't know where it went wrong. So please tell me where it went wrong, what you don't understand exactly, so that I can re-explain. I hope Chidera is still here. Every other person in this live, I'm not hearing from every other person. Wow, from horizontal. Okay. Okay, here's what I'm going to do. But okay, do you people understand the diagram? Do you people understand the diagram? Okay, I'm going to go over it now. Do you people understand the diagram? Okay, very good. If you understood the diagram, so let's take a look at it together. If you understood the diagram, then we can now take a look at it. In fact, I can switch this time around. I can start from the vertical. Anyone I decide to start with, it will still work. So now, this vertical, by the way, to understand this thing better, you guys need to check some videos out on my YouTube where I patiently explain some of these things there. So you will need to check my YouTube out. I explain some of these things patiently, especially all this resolution of force, equilibrium, and the likes. So that will help you better. So, but let me explain what I'm doing in this place now. So basically, what you do here is that you look at vertical. What are the things happening here at the vertical? In this place generally, okay, another question. You people know where I got my 10m from, Abi? It is mg. Mg is mass times acceleration due to gravity. In that question, I was not given m, so I just said g is 10 times m, so I got 10m. That's where I got this 10m from. So let me continue. So in this system, we have three forces acting in the system. We have number one, we have the normal force acting in the system. So that's number one. Number two, we have the frictional force. And number three, we have this 10m force acting in the system. So in the vertical direction, there are these major guys happening there. You see, this 10m has what we call horizontal and vertical component. FR has only horizontal component. There is no dealing with the vertical. While N has only vertical component, there's no dealing with the horizontal. The only guy that has for both is 10m. So when I want to deal with the vertical now, the two things that I will deal with will be N and 10m. So the vertical will now be, so since this guy is going up, so I will have positive N. Now the 10m is down. So I will have minus 10m. However, this 10m is inclined at an angle. So you see, because it is vertical, it does not mean that you will use sine. Please take note. If the angle, this is the question you will ask yourself. You will ask yourself, which axis am I? You will answer that question. In this case, vertical. Then you ask a question again, ask yourself a question again. Where is the angle made with? That is the angle that I'm given, where is it made with? If the answer is the same, then you will use cosine. Please take note. So there's nothing like, y-axis is sine and x-axis is cosine. There's nothing like that. It only works when the angle is made with x-axis. So you ask yourself that question. Which axis am I dealing with? Vertical. You also ask yourself, which axis is the angle made with? If the result is the same, vertical as well, then what you are going to be using is cosine of that angle. Now, so because there is no motion in this vertical direction, the object is not moving up and the object is not being compressed down. So the net force will be equal to 0. That implies that you can solve for your n in this place. That will be 10m cosine 30 degrees. When you solve this thing very well, that's 10 cos 30. So you will have 8.66 m newtons. So that is how I resolve the vertical. Now let's now resolve for horizontal. For horizontal, we know that two things will be acting in the horizontal: the frictional force and the 10m. Nothing concerns n again. So in this place we have 10m, but let's ask ourselves the question again. Which axis am I dealing with? Horizontal. Where is the angle made with? The angle was made with the y-axis, with the vertical. This answer, they are different. Whenever you get different answer to these two questions I just gave you, you will use sine of the angle. So this has to be sine 30 degrees. Then frictional force, since 10m is to the right, frictional force is to the left, so we have minus Fr. Then I told you, once you are done finding resultant force, you always equate it to what? Ma. The reason why I didn't equate it to Ma here is because there is no motion in the vertical, so hence the whole acceleration will be equals to 0. So guys, give me a feedback. Does it make sense now? Do you like grab the whole thing now? By the way, you still watch that video for a proper understanding. Okay, only one person said they understand now. What about the rest? Okay, very good. Very good, very good. Well done, guys. So now we can now proceed. We can proceed now. So I will now solve this now. This will now be sine 30 is 0.5, so that will be 5m minus Fr equals Ma. Now, what we also know is that frictional force is mu times normal reaction. I know my mu from the question, 0.35. Normal reaction, I've gotten that one as 8.66 m. So that will be 0.35 times 8.66. So that gave 3.031. So finally, I will substitute this into this equation. So this equation becomes 5m minus, instead of frictional force, I already have this, 3.031 m equals Ma. And then this will be 1.97 m equals Ma. Divide both sides by m. That implies that acceleration is 1.97 meters per second squared. So that was how we got that. Okay, so now the Roman figure 2 part. You were given omega as 0.6 rad per second, and you were given the linear speed as 3 meters per second. So this one is a very easy question. We want to look for the acceleration towards the center. That means that we are looking for the centripetal acceleration, which is v squared over r. So basically, what don't I have here? Actually, another way you can also see this is that, because actually v equals omega r. So from this place, you can have your AC equals omega squared r, depending on whichever thing you are using. And also, if you have only v and omega, you can also write that in terms of this guy. If you only have v and omega, so that will be r equals v over w. So when you put v over w in this place, divided by v over w, so you have omega v square omega. But let's not stress ourselves. Since v equals omega r, then I can get my r, meaning that 3 meters per second equals 0.6 times r. So r will be 3 divided by 0.6. So what's that? 3 divided by 0.6, that's 5. So r is 5 meters. So hence, what I'm looking for is centripetal acceleration. That will be 3 squared over 5, which will be 9 over 5. And that's 1.8 meters per second squared. So I've been able to get the two results like that. So the correct answer to this question will be D. So question 48 now. A man hears his echo from a nearby ease after he shouted 2 seconds after. If the frequency of his voice is 260 Hz and the wavelength is 1.29, how far away is the hill? First of all, we know that frequency is f lambda. And sorry, velocity is f times lambda. So that implies that in this place we can first of all find the velocity. So the velocity will now be 260 times what? Times 1.29. So 260 times 1.29. So that's 335.4 meters per second. Also, when echo is happening, velocity is 2x over t, where x is the distance. So that means that x in this place will be vt over 2, and that will be 335.4. They say he had it 2 seconds later over 2, so 2 will cancel 2. That will be 335.4 meters. So that means that the how far away we are looking for is that. Okay, question 49. Question 49. A copper calorimeter of mass 60 grams. So mass of calorimeter 60 grams contains 100 grams of oil. Mass of oil 100 grams. And then is at 20 degrees Celsius. Initial temperature 20 degrees Celsius. Now, if oil is containing this thing, both of them will share this temperature, please. Whenever you have a substance inside a container, both of them will share the same temperature. So a piece of ice at 0 degrees Celsius. So we now have a piece of ice. Let me say this one is oil. Mass of ice, we don't even know. Okay, they gave us mass of ice was given to be 25 grams. Now, if that is the case, then what's the question asking us to do? And the temperature of ice was at 0 degrees Celsius. So the question now says that calculate how much ice will be left when the temperature of the calorimeter and its content becomes steady at 0 degree Celsius. So final temperature is 0 degrees Celsius. So what you want to do here is that don't even think about your ice yet. Forget about the ice. Deal with this other guy, because heat lost by one body equals to heat gain. Since both of these guys are the same temperature, your oil and your calorimeter are at the same temperature.